Okay, YouTube, I want to take a quick look at the next step in the chess computer, or the chess engine, it's probably more correctly called, which is move generation. I just want to show this video where we get started. So I've written here some notes. So the first goal, which we may not achieve in this video, is to generate all the legal knight moves. And I think the structure of the function we're trying to write is it will loop through all the pieces. For each piece it will try to generate, or let's say it will loop through all the pieces of the color that is active. Then it will generate the moves for each piece, and then it will collect the moves, or probably it will collect the final positions in some data structure. And we may need to add some more information, like the occupancy map, like we saw we needed for a lot of the attacks, or maybe even color-based occupancy, because you want to handle it differently depending on a square is occupied by the same color or the opposite color. So I think this is the function signature we want. Game, which is the game struct that keeps all the information about the state of the game, and probably will have to add these to it. And then it will return a vector of the positions you can reach from this position via legal moves. So, and to test it, let's look at main. I have these two test strings, or test positions, not a lot and not a lot too. And not a lot has a black king, a white knight and a white king. And not a lot too has a black king, two white knights, arranged in such a way that they will block each other partially. So we test that works, and a white king. So let's see how they look. Now, probably we should change how games are displayed. Let's find the toString function in here. This one. So let me zoom out a little bit. Oops. Again, toString, please. Okay, so what we do now when there's an empty string, as you can see over here, we push like the name of the string, A8, B8, whatever. But let's not do that right now. Let's push just a dot, and let's see how that looks. A little bit easier to read. So let's go with that for now. So as you can see here, we have just a knight kind of in the middle of the board. It will not hit the king, either of the kings. So the moves we should get out are quite simple. The other position has two knights, but you can see that they can hit each other. So when we calculate the moves, of course we should get one less for each knight than we would otherwise. So let's try to get started. Now let's remind ourselves what's in this game struct. And here we go. So let's say maybe we'll refactor it, of course, but let's say new positions. This is what we will eventually return, and then for piece in game.pieces, let's say if piece, and I think piece has a color field. Piece has a color field. So if piece.color equals game.activeColor, then it's a color we want to. It's a piece we want to handle, and then we can say match. Let me just again go to the piece struct. If the well, let's look at the piece type, and based on that we will handle it differently, because if it's a knight we want to do something, pawn, rook, queen, king, you know, we want to handle them all differently. But for now, let's say the kings, they cannot move, so we'll do nothing. Obviously it's not fully correct. And then we will say piece type is not yet supported. Actually, come to think of it, why do we add the kings? Let's just remove the kings. There's no check whether a position is legal, so this should still be fine. So we don't have to have this weird case that we may miss. So piece type thing is not yet supported. And there we go. In the end, let's keep the to-do for now. But in the end, we want to return new positions. Let's add a return statement. So this is what we want to do. And now here I need to create a new game, the position that you get from applying each of the moves. And then add it to the new position. So let's say generate knight moves, whatever, for this piece, new positions. And I don't want to move it, I want to just mutate it. And starting from this position. So something like this. Right, we want to generate knight moves for this position, this color. And I want to do it starting from this position. That's represented by the game, and I want to put the new positions into this vector field. So let's just do that. And also I don't want to move it out, so let's say we just have a reference to a piece. We have a reference to the game. I mean, I'm pretty sure. Okay. And we have the, you know what, let's not do that. Let's say this, and then there should be something like extend or whatever. And then this guy will just return a vector of games. Let me check that this extend function actually exists. 1 second. Yeah, it looks like it should be fine. All right. So let's look at our knight attacks again here. Should already import it. So we can say let attacks be okay. Here's an interesting thing. So we agreed that we wanted this knight attacks to be initialized in the beginning, but then the question is, where do we place it? So I'm kind of thinking that it should live inside the game structure, but then the game structure will have a lot of things inside it all of a sudden, but maybe it's okay. So where is this? Here, I guess. This should definitely also be refactored at some point. Cleaned up. And I think, wasn't it just called new? It's called initialize. Let's call it new because there we go. Okay, so now we can say that let's remember, so the knight attacks has a bitboard which is the attacks for each square. So we can do something like game knight attacks for the piece. And again, I cannot remember what I called all these things, so you'll have to bear with me. Okay, it's just called position. So this should work. Let's do some print debugging. And we'll make some tests. Test. Generate knight moves. So we will need a game. Let's hijack this thing. And then we will need a piece. Let's say game.pieces, just because there should only be one piece, and then the game, of course, and that should do it. So I'm a bit tired of writing like cargo T or compile or whatever, so I'm gonna set up some hotkey for my Emacs. 1 second. Okay, I think that should work. In case you're interested, here's the function. I just run a shell command cargo T with the file name of the current folder, and then I add this no capture, so anything that's printed during the tests can be shown. And then here I bind it to Control Q, and that should work. But we have some compile errors, so let's see here. First line 31, fair enough. We forgot this guy. Now line 40. Yes. This should be game. Unused imports, whatever. New. Okay. This guy has to be public. And expected U size, right. Expected U size. So I made a mistake when I should be knight attacks. Oops. And warning, error. Okay, game RS 327 and knight attacks. Okay, now we need to look at the piece guy. And these things should be public. And there's another error. Knight. Okay, it's just a little bit too many T's. And cargo check now. Not cargo, but cargo check. And another error in here. Just did debug print. Cannot index. Because we have to do this. Okay, that doesn't work either. Do I put public here or something? Okay, the type. Fine, I'll remove the to-do. Okay. The type array of U64 cannot be indexed by 64. Why not? And why does it think it's a big type? Let's do this for now. Function takes 0 arguments, but 2 was applied. What? Okay, let's look at the other error first. Great. Generate night modes. I mean, it clearly it expects 2 arguments, right? It's because it's shadowing, so like that. Okay, so I'm warning the pattern binding is new. Okay. Game piece is partially moved to this call into eta. We don't want to take ownership, is that it? Okay, whoops. Okay, let me fix. No, okay. It's important to see the process and how annoying it is sometimes. Cannot move out of game.pieces which is behind a shared reference. Game piece has the type vector game piece which do not implement copy trade. Help. Consider iterating over a slice. Whatever you say. Help. And again, I don't really want to own it, I just want to do that. Okay, so it didn't print anything, which is weird. Let's just for now say allow unused imports. So we don't get that thing. And I was pretty sure it was going to print something. Hello? And if I run myself. Okay, so now it did something, so probably there's some bug in my thing here, but now it looks fine. let's get this thing and put it here. So command is that. And do command, and then we'll also do message command so that we can see it. Okay, fine. Okay, so here we see the commands running, which looks fine. But it's not finding that. Okay, so the problem is the okay, 1 second. Okay, I cannot get it to work right now, so I am going to just do something very stupid now, which is make it work only for this file. What's with the coloring now? That's great. Right, like this. Now it should work. Now we run it. It actually runs the stupid test. Great. And I can remove this as well. Okay. Let's try to do something now. So here we print a bunch of attacks. That's good. But now, a bunch of bitboards, but now I want the one at the position. And try that. Again, that doesn't work because it says that this array cannot be. Okay. Do we have to say use size? Oh, that worked somehow. How? Okay, how it panicked. Okay. Okay. Now I remember. It's because this is. It is because this is like a bit flag thing. So we need something like index to, we need position to index, something like that. Bit to position, index. Do I have that? Really should have that. Okay, we can do bit scan, I guess. So I bit scan this and not found in the scope. Okay, fantastic. Still fails in the to do, but now at least we have this thing. Do I have a nice way to print it? I think I do. Print bitboard. Let's do that. And then we also want to get that up here. Print bitboard. Interesting. Can I remove this then? Fantastic. Now we have the moves. Now we just have to check the occupancy. See if any of those squares are occupied by our own pieces. So check if any squares are occupied by our own pieces. Remove those squares. And we also need to check if any squares are occupied by enemy pieces. Remove those pieces if that square is selected as the move. Something like that. But let's look at that next time, because now I have to go.